So one more example here, and it's a big one, part C. 2x plus y minus 3z equals 4. Negative x plus 4y minus 6z equals 4. And x minus y plus z equals 0. Okay, so at first, this just seems like maybe another style like we saw in example part A. But turns out there's going to be something that happens along our um, path of solving that we didn't encounter. We really need to give it attention. So okay, so I notice all three equations have x, y, and z in them. So I've still got my same goal, of course, get two equations and two variables. And this is the hardest case. It's also the most common, where all three equations have all three variables. So I'm going to take two pairs, cover that back up. I'm going to take two pairs of equations and eliminate the same variable twice, just like we did in part A. So I'm going to look at this and I'm going to think to myself, okay, I need to take two different pairs of equations and eliminate the same variable each time. Well, do any of these seem more natural or easier to eliminate than others? And, you know, at this point, different classes, different people see different things. You might see, oh, z, I could multiply by 3 here and add it with that. I could also multiply by 6 and add it with that. And I could eliminate z twice. Yep, sure could. Hey, y, I could combine equation 1 and 3 and eliminate y. And then I can multiply this by 4 and put it with equation 2, eliminate y. That'd be two pairs. Or you might say, hey, x, I could just add 2 and 3 and eliminate x. And then another way, I can multiply by 2 and add it with this and eliminate x. All good ideas. And none of them is really any more difficult than the other, I wouldn't say. I'm going to pick x to eliminate. Just why not? It's the first. Any of them would work. I'm going to go with x. So I'm going to eliminate x two different ways. Here they are. I'm going to multiply equation 2 by 2 and add it with equation 1 to do it the first time. And to eliminate it the second time, I'm just going to add equations 2 and 3. And then I'll have two equations with x eliminated, so two equations with y and z. Okay, let's go ahead and perform that. So, sorry, it doesn't all fit. This is multiplying equation, that's just equation 1. 2x plus y minus 3 is equals 4. That's the original equation 1. Here is equation 2 multiplied by 2. Negative 2x plus 8y minus 12z equals 8. Everything multiplied by 2. Of course, I'm doing this so that when I add them, the x is eliminated, and I end up with 9y minus 15z equals 12. Okay, looks great. Now you notice in this equation, I can actually simplify this a bit further. All three coefficients are a multiple of 3. I could divide each of these by 3 and get 3y minus 5z equals 4. Again, dividing each term by 3. Okay, so number 1 is good. Number 2 is simpler. I'm just going to add equations 2 and 3. So there's equation 2. There's equation 3. Didn't change anything. I can add them. X is gone. And what is that going to give me? 3y minus 5z equals 4. Okay. So we eliminated x twice. So we've got these. Do you notice anything about our two equations? And we could never have seen this coming. They're the same equation. We could not have realized that any sooner. This is interesting, and it's going to lead us to a certain type of answer. 3y minus 5 equals 4 appears twice. Well, let's just go through our procedure as we normally would, we'll try to solve this for y and z. And we'll just see what happens, and then something will really jump out at us. Okay, so let's say I wanted to eliminate y so I could solve for z. Well, 3y and 3y, so one of them needs to be negative to eliminate. I'm going to multiply the first equation by negative 1. Multiply equation 1 by negative 1. Okay, I'm going to pick that up on the next page. So here we go. I multiplied the top equation by a negative. So I end up with negative 3y, and it became plus 5z equals and negative 4. I kept the same the equation 2 the same, didn't change that one. Okay, so now when I add, I eliminate y like I wanted to, but I also eliminate z. Everything on the left here is eliminated, so I get a 0. Also, on the right side, negative 4 plus 4 is 0. I got 0 equals 0. You think to yourself, oh, well, 0, I can't, what am I going to do with it? I can't solve for z. You're right. So we're going to stop right here. And it turns out we're just going to give our answer. The answer to this is, it'd be a lot more interesting in class, and I could see what people think. I'll just go ahead and tell you, if you get a statement like 0 equals 0, it's infinitely many solutions. Why is that? Well, think back here. The whole idea is, what values of y and z, give me two values, y and z, such that 3y minus 5z equals 4. Okay, I might take a moment and come up with a value of y and z so that when I put them together, I get 4. That same value of y and z is going to make this happen, right? Negative 3y plus 5z equals negative. That same value of y and z, no matter what combination, I can pick lots of different combinations of y and z. All of those are going to make both of these true. If one's true, the other's true. So there are infinitely many combinations. Now, it doesn't mean any y and any z, but whatever y I pick, there's a z out there that will make this equal 4, right? And those same values of y and z will make this one up here equal negative 4. Okay. Also, for those combinations of y and z, I could go back and there would be a value of x. So it's not any value of x combined with any value of y combined with any value of z. That's not what we're saying. But what we are saying is, if you pick one of them, say pick y, then I can figure out the z that goes with it, and then we can go and figure out the x that goes with that. But then I could pick y to be something different, and then we'll figure out the z that goes with that different y, and then the x that goes with that, and there's another solution. Okay, so there's infinitely many. If you come to this sort of a statement, you can stop and know that. This is called an identity. It's not so much that it's zeros. That's not what's important. It's that it's the same number equals itself. So if this said 2 equals 2, that would still be an identity. Usually, though, because the way elimination works, it's going to be 0 equals 0. That's usually what comes out. Okay. We could have identified this and just said infinitely many solutions back at this step. As soon as we realize it's the same equation, I'm fine if you just stop right there and write infinitely many solutions, circle it, and be done. As soon as we see that equation twice. But we definitely need to stop here. I mean, there's nowhere further to go. I mean, we got to say it then. Okay. So let me show you, that's the answer to part C. Done. Infinitely many solutions. Let me show you a similar case when there's no solution, because those are kind of the two extremes. So just for example, let me just present this. I'll show you all of it. What if, we were kind of going by the same logic and the problem was unfolding, and we ended up with negative 3y plus 5z equals negative 4, just like we did a moment ago. and 3y minus 5z equals 2. And then we went to say eliminate the y's, okay, but then the z's eliminated also. But then when we go over here, we end up with some number. So negative 4 plus 2 is negative 2. Okay, so the difference is it's not 0 equals 0, it's 0 equals something else, right? Well, 0 does not equal negative 2. So that's just not going to happen. We would call this a contradiction. If you end up with a contradiction, then the answer is no solution. There is no values of x and y that are going to solve that. And if you go to the larger system of 3 equations, there's no values of x, y, and z that are going to solve it. Solution does not exist, no solution. Okay, you guys needed to see those. I'm going to stop 4.4 here. Go check out homework. Also, a lot of these I've been presenting questions at the end here for you guys to try out. These problems are long though, and there's many different approaches. So if I was to present one and then say, hey, let's do it together, I might take a totally different approach than you might. So I thought it best not to have the practice problems in this for this section, but we'll see them again in later sections in chapter 4. The homework will be plenty enough for you to wrestle with, and come to the live session too. See you there.